You've heard all three. AI, machine learning, deep learning. They get thrown around in headlines, job descriptions, investor decks, and TED Talks, usually by people who use them like they mean the same thing. They don't. And the confusion isn't just annoying. It's actually costing people. Developers building the wrong tools. Companies investing in the wrong technology. Professionals missing out because they don't speak the language of what's actually happening. So here's what we're doing today. We're going to draw 3 clearly separated boxes, explain what goes in each one, show you how they connect, and give you real examples you already know, so it actually sticks. By the end of this video, you won't just understand these 3 terms. You'll be able to explain them to someone else. That's the bar. Let's hit it. Before we get into differences, you need to understand how these 3 things relate, because most people think they're 3 separate concepts. They're not. They're nested. Think of 3 circles. The biggest circle on the outside is AI, artificial intelligence. Inside it is a smaller circle, machine learning. And inside that is an even smaller circle, deep learning. Every example of deep learning is machine learning. Every example of machine learning is AI. But not every AI is machine learning. And not every machine learning system uses deep learning. Hold that image. Nested circles. It's going to anchor everything that follows. Artificial intelligence is the broadest term. It means a computer system doing something that normally requires human intelligence. That's it. That's the definition. AI is not one technology. It's a category, like saying vehicle. A bicycle is a vehicle. So is a Boeing 747. They both qualify, but they are not the same thing. When people say AI in casual conversation, they could mean a rule-based chatbot from 2005, a recommendation engine on Netflix, a self-driving car, or GPT-4. All of them are AI. None of them are the same technology. The first AI programs weren't trained on data at all. They were expert systems, massive lists of if-then rules written by humans. If the patient has fever and cough, suggest flu. That's AI. Simple, brittle, and very limited. This is an important point. AI existed before machine learning became mainstream. Early chess programs in the 1950s were AI. Deep Blue in 1997 beat the world chess champion without a single line of machine learning. So AI is the umbrella. Everything else lives under it. Machine learning is a specific approach to building AI, and it flipped the traditional model completely. In traditional AI, humans write the rules. In machine learning, the machine discovers the rules itself from data. Here's the shift. Instead of a programmer writing thousands of if-then statements, you give the system a massive amount of labeled examples, and it figures out the pattern on its own. You want a spam filter? Don't write rules. Show it 50,000 emails. Label them spam or not spam. The algorithm figures out what makes spam look like spam. This is machine learning. And it changed everything because it scaled. You can't write rules for 1 million edge cases, but you can collect data on 1 million edge cases and let the machine learn from them. The key word is train. ML models are trained on data. They are not programmed with logic. They are shaped by examples. Classic machine learning includes algorithms like linear regression, decision trees, random forests, and support vector machines. They're powerful, widely used, but they have a ceiling. Here is the limitation. Classic machine learning works brilliantly when you can define the features manually. A feature is a measurable input. If you're predicting house prices, your features might be square footage, number of bedrooms, and location. A human picks those, feeds them in. The algorithm learns the relationship. But what happens when the features aren't obvious? Take image recognition. What is the feature of a cat? How do you describe in numbers what makes a cat? You can't just define it. There are infinite combinations of pixels, shapes, and textures that all mean cat. Classic ML struggles here. It relies on humans to define the meaningful inputs. And for unstructured data, images, sound, raw text, video, humans simply can't do that at scale. This is the exact problem that deep learning was built to solve. Deep learning is a subset of machine learning that uses layered neural networks, loosely inspired by the structure of the human brain. The word deep refers to the depth of those layers, not complexity, not sophistication, literally depth, how many layers of processing the data passes through. Here is the key insight. Deep learning learns its own features. You don't tell it what to look for. You give it raw input, millions of raw images, raw audio, raw sentences, and it builds its own internal representations of what matters. In the early layers, a neural network might learn to detect edges. Middle layers detect shapes. Deeper layers detect objects. The deepest layers detect meaning. Nobody programmed any of that. It emerged from training. This is why deep learning dominates tasks involving unstructured data, image recognition, speech recognition, natural language processing, translation, content generation, all powered by deep learning. GPT models, Stable Diffusion, Google Translate, Siri, Tesla Autopilot's vision system, all deep learning. Let me make this concrete with things you already use every day. Your email spam filter, machine learning. It was trained on millions of labeled emails. It uses structured data, sender, subject line, keywords. Classic ML algorithms are perfectly suited for this. Your phone's Face ID, deep learning. It uses a convolutional neural network that processes raw pixel data from your face and builds internal feature maps that are unique to you. No human defined what a face looks like. The network figured it out. Netflix recommendations. Machine learning. Structured data. What you watched, how long, what rating, what time of day. Collaborative filtering algorithms find patterns across millions of users. GPT-4, Claude, Gemini. Deep learning. Transformer neural networks trained on hundreds of billions of words of text. The scale is staggering and the architecture is deep. A chess engine like Stockfish. AI, but not machine learning at all. Pure algorithmic search and evaluation functions written by humans. No training, no data, just logic. Self-driving cars. A combination. The vision system that sees the road, deep learning. Route planning, classical algorithms. Decision-making under uncertainty, a mix of both. You interact with all three every single day, usually without knowing which one you're dealing with. Now let's put them side by side so the distinctions lock in. AI is the goal. Build machines that simulate human intelligence. Machine learning is a method. Let machines learn from data instead of being explicitly programmed. Deep learning is a technique. Use multi-layered neural networks to learn features automatically from complex, unstructured data. Different scope, different approach, different use case. When do you use classic machine learning? When your data is structured, when your features are known, when your data set is smaller, and crucially, when you need interpretability, meaning you want to understand why the model made a decision. When do you use deep learning? When your data is unstructured, images, audio, text. When your data set is massive. When raw accuracy matters more than explanation. And when you have the compute power to train a large model. When is something AI but not machine learning? When it's rule-based. When it's a search algorithm. When a video game character follows a decision tree. That's AI. But it's not learning anything. So why does any of this matter beyond being able to win an argument at a tech meetup? Because when you understand the distinctions, you understand the limitations. AI is not all deep learning. You don't need a neural network to build something intelligent. Sometimes a simple decision tree is faster, cheaper, more explainable, and more reliable. Deep learning is not always better. It needs enormous amounts of data. It requires significant compute. And it's often a black box. You cannot easily explain why it made a specific decision. In medicine, finance, and legal systems, that explainability problem is serious and sometimes a legal requirement. Machine learning is not magic. It finds patterns in the data it was trained on. If that data was biased, the model is biased. If that data didn't cover your use case, the model will fail confidently. Understanding which tool does what means you can ask better questions. Evaluate technology more critically. Make smarter decisions as a professional, whether you're building it, buying it, or simply working alongside it every day. That's why the language matters. Not for trivia, for thinking clearly about a technology that is reshaping every other industry. Here is the mental model you take away from this video. AI is the destination, the goal of machines that can think. Machine learning is one road to get there. Let machines learn patterns from data. Deep learning is a vehicle built for that road, powerful and fast, but it needs a lot of fuel in the form of data and computing power. Not every road trip uses that vehicle. Not every AI is machine learning. But when the terrain gets complex enough, images, language, sound, deep learning is the vehicle of choice. Remember the nested circles. AI contains machine learning. Machine learning contains deep learning. And the next time you hear someone use these three terms like they're the same thing, you'll know exactly what they got wrong. Here are three key takeaways. 1. AI is the umbrella. Machine learning and deep learning both live inside it. 2. Machine learning learns rules from data without being explicitly programmed. 3. Deep learning learns its own features. No human definition required. For more content, please like and subscribe.